2 solving compound inequalities. When we graph these, we're going to have two separate lines. These lines are either going to connect between two different numbers, or they're going to go opposite ways. Okay, so we want to remember too, when we're doing these, when we're graphing these, you're going to have either a closed circle or an open circle. And an open circle means that you have either less than or greater than. That closed circle means that it's also equal to, so it's going to be less than or equal to or greater than or equal to with these numbers. So if we look at the first example, it says to graph the solution set of the conjunction x is greater than -2 and x is less than 3. So if we have an and statement, those lines are going to connect. So that line, there's only going to be one line drawn between two numbers. So if we have x is greater than -2, we're going to have an open circle on that -2. If we have x is less than 3, we're going to have an open circle on 3. And that line, if you see, these signs point towards each other. So that line's going to go in between those two lines. So again, we can draw this on the number line. We can draw this line above the number line, but as long as the circles are on the number line at the number that it's supposed to be at, and then the line that you're drawing is touching those circles. It has to touch those circles. If we look at example 2, we now have the disjunction of x is less than or equal to -4 or x is greater than 1. So this is an or statement. Those or statements are going to have two lines that go opposite directions. And if you see here too, we have a less than or equal sign on -4, so we're going to have a closed circle on -4. We're still going to have an open circle on that 1 because it's just greater than 1. So that x is less than or equal to -4, that line's going to go to the left because that sign points to the left. And then that x is greater than 1, it's going to go to the right because it points to the right. Some of these are going to be already set up together to where we have an and or statement and we're solving them. When we're doing that, we're doing the same exact thing that we have done with just separate inequalities. However, now we're going to be doing it to both sides of each of those inequality signs, especially with an and statement. So with this example 3a, we have 3 is less than 2x plus 5, which is less than or equal to 15. So we want to undo the addition or subtraction first from the middle outward. If it helps you, you can rewrite this statement as two separate inequalities. So 3 is less than or equal to 3 is less than 2x plus 5, as well as the 2x plus 5 is less than or equal to 15, and then solve the two separate ones. Or you can do it together, totally up to you. So if we do it together, we're going to subtract this 5 first from everything. So the middle and the left and the right. This is going to leave us with 3 minus 5, which is -2, is less than 2x, which is less than or equal to 15 minus 5, which is 10. From here, we got to get x by itself in the middle, so that we're going to divide everything by that 2. So the middle, the left, and the right. So the -2 divided by 2 is -1, which is less than x, which is less than or equal to 5. You want to remember when you're doing this, if you're dividing everything by a negative, those signs are going to switch. Those inequality signs are going to switch. So if we go to graph this, first off, you want to look, is my smallest number first? Yes, that -1 comes before the 5. -1 is less than 5. I'm okay. If it doesn't, you want to rearrange this to where your smallest number comes first. In this case, it does, so we just can graph. So we're going to look for that -1. 0, 1, 2, 3, 4, 5. Okay, and we're going to look at that -1. It says that x is greater than -1. So that sign, that circle is going to be open and that line is going to go inward. Okay, you got to look at this as two separate ones. Like I said, you can rewrite it as x is greater than -1. That sign points to the right, so the line's going to go to the right. On the 5, we're going to have a closed circle. We have x is less than or equal to 5, so that sign's going to the left, so this line's going to go to the left. So these lines are going to connect with one another. So you have not only the x, or sorry, the -1 is less than x, which is less than or equal to 5, but also the graph. When we look at this or statement here, we have 7 minus 2y is is less than or equal to 1, or 3y plus 10 is less than 4 minus y. So first work with the 7 minus 2y is less than or equal to 1. What do we move over first? We're going to move that 7 over. So we're going to subtract each side by 7. We get negative 2y is less than or equal to negative 6. Then we're going to divide each side by that negative 2. We're dividing by a negative, so we're flipping that sign. So y is now greater than or equal to positive 3. Work with the other inequality. You have 3y plus 10 is less than 4 minus y. I'm going to move that y over first by adding it to both sides. We are left with 4y plus 10 is less than 4. Now I'm going to move the 10 over by subtracting it. And I get 4y is less than negative 6. Now I'm going to divide each side by 4. Oops. Green. And I'm going to simplify this as y is less than negative 3 over 2, which we also know is negative 1.5. So look at these two sets. You have one that's dealing with a negative 1.5, one that's dealing with a 3, which is less than the other, the negative 1.5. So that y is less than negative 3 over 2, and then we also have y is greater than or equal to 3. Do these two inequality signs point opposite ways? Yes. So this is definitely an or statement. If it didn't, and they both pointed the same way, you'd have to look at which inequality gives you the greater solutions. So if this was, let's say, y is less than the negative 3 over 2, or y is less than or equal to 3, you would just give me that y is less than or equal to 3 because it includes the other inequality when it's drawn on that number line. So on your number line here, we're going to have negative 1, 0, 1, 2, 3. So we have an open circle on negative 1.5, which would be about here. And then we have a closed circle on that 3. Our signs are going opposite ways, so that line for the negative 1/2 is going to go to the left, and the line for that 3 is going to go to the right. So again, we have this as our solution, as well as the number line. If we look at another example, we're dealing with an and statement here, for example, C. So we have negative 2 is less than 5 plus 3x, which is less than 20. So what do we move over first? That 5. We're going to subtract 5 from both sides. The negative 2 minus 5 is negative 7, is less than, bring down the 3x, which is less than 20 minus 5 is 15. From here, you're dividing 3 for every part, so the left, the middle, and the right. The 3's cancel out. This negative 7 divided by 3 is also negative 2 and 1/3. So if it helps you to graph based off of that, turn it into a mixed number, which is less than x, which is less than 5. 15 divided by 3 is 5. So now look at your graph. If you're going to draw a graph, you have to include the negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5. So what kind of circle do we have on the negative 2 and 1/3? It's going to be an open circle. So our circle is going to go about here. And then we also have an open circle on 5 as well. Look at the way this says. It says x is greater than negative 2 and 1/3. Your line's going to go to the right. X is less than 5. Your line's going to go to the left. Are they going to connect? Yes. So it's just the line between the two circles.